Hello, welcome back to AGT STEM. Today we're going to be watching a video about magnesium. So, without further ado, let's hop to it.
Magnesium is one of the lightest elements. It's right at the beginning of the periodic table, and in fact, it's the first of the light metals that you can actually use.
It's bright.
Lithium and sodium react violently with water, so you can't really use them as a metal. And beryllium is fantastically poisonous, so unless you're using it in the lab where you can be sure that nobody's going to touch it, it's useless. So magnesium is the lightest metal you can use.
That's cool.
So for example, if you're trying to make mobile phones that are really light, then you can make the frame of the mobile phone out of magnesium. You can use it for laptops. There's a professor in Germany who's promised to send me a laptop frame made of magnesium, but it hasn't arrived yet.
So another classroom classic. Normally comes along in chemistry lesson number 3, I guess. Time to combust a reactive metal in the air. So the reactive metal we're going to look at is magnesium.
The other thing that's good about magnesium is that there's a lot of magnesium about in the world. So it's not an element that's difficult to get. If you look at this periodic table here, which is from Barcelona, so it's in Catalan, the areas of each element are approximately the abundance in the world. Some of the rarer elements have a slightly bigger squares than they should do, so you can read the letters, but you see magnesium here is pretty large, so magnesium and sodium are pretty common. Beryllium is much less common, and lithium is even less common than that. So there's lots of magnesium.
Magnesium is very light, it's very cool reactive, very pliable metal. It's very nice. It's easily alloyed with things like aluminium and other light metals to make very strong, very robust materials. Used in construction, it's used in high performance components of cars.
When I was a child, when we had indigestion, we were given milk of magnesia, magnesium oxide in water, which came in these really nice blue bottles, sort of white looking liquid. Didn't taste very nice, but it was meant to be good for you. I'm not sure if it was.
It's used in the hulls
of
ships, you know, like warships, things like that. So incredibly strong, incredibly light, but incredibly reactive if you give it enough energy. So we're going to combust it in the oxygen and we're going to see what happens.
Magnesium, as you know, burns. And one of the ways that magnesium used to be used was for photographic flashlights. And you use bulbs like these, which contain magnesium inside a bulb filled with oxygen.
Huh.
And for each photograph, you had to put this on the top of the camera. So I've got one here that I've taken out. So if you look at it, so much heat has been produced by this tiny amount of magnesium that it's melted the glass.
So let's see what happens when we light it. And you can see, very fierce, bright white light, like classical glow. Everyone's seen this in the chemistry lab at school. Fantastic reaction.
It's one of the few metals which is meant to burn in nitrogen. In theory, you can take a piece of magnesium, set fire to it in air, so it's burning well, and then plunge it into nitrogen gas, and it should continue burning. I have tried this experiment lots of times, and it's never worked. In fact, for 25 years, I demonstrated this experiment to my lecture class when I was talking about nitrogen. And every time it didn't work. And the students thought, the poor professor, he's been made a fool of, it hasn't worked. And they didn't know that it's never worked. And I would have been more surprised if it had done. But it taught them a bit about the chemistry of nitrogen and magnesium.
Why did you keep doing it if it never worked?
Because it's a really good experiment, because it got such a good reaction from the audience.
Because it went wrong?
Yes.
You're playing the fool on purpose?
Yes.
So this is this magnesium metal, but the magnesium metal here is not the ribbon which we normally see in perhaps scientific labs or perhaps in school labs. This is a very, very fine powder of magnesium. So what we're going to do in a moment is we're going to bring on a really quite powerful torch, a gas flame, and we're going to see what happens when we sprinkle a little bit of this material into the flame.
Magnesium is also very important in all our lives.
And dangerous.
Because magnesium is found in the green pigments in the leaves of all plants, in chlorophyll. Chlorophyll is an organic molecule, carbon, hydrogen and nitrogen, and in the middle there is an atom of magnesium. And it is chlorophyll which captures the sunlight and transfers it eventually to cause the reaction of carbon dioxide and water to make all the sugars and other things in the plant. If that didn't happen, none of us would be alive, because we all rely, either directly or indirectly, on plants to give us the energy to live. I don't understand completely the mechanism of photosynthesis, because the energy that's absorbed by one molecule is transferred to another and another one, as it were, along a chain. But the magnesium is very important. If you don't have magnesium there, it's not nearly as efficient.
Let's light it again.
It looks almost white in that picture. Well, thanks for watching, and we'll see you next time. Stay smart. Bye.